So looks like we are now ready to start taking a look at our code and review the step-by-step process on how we deploy this application as a microservice-based application. The first step of our code review process is going to be to take a look at how we convert our existing code into containers. And in the subsequent videos, we will look at how we now take those containers and deploy into the Kubernetes cluster as microservices. As we have already seen how we have set up our code structure in our Visual Code Studio, we clearly see that there are multiple components that are being considered here. Our middleware layer has two components, orders and products. As mentioned earlier, the core reason for separating our middleware application into two separate independent components was the core idea behind developing microservices. So it's not just enough to take any application, containerize it, and deploy it in Kubernetes to be called as microservice. You really need to architect your application into microservices components. So we took two independent components, that is, one that deals with order creation and listing, and another that deals with product creation and listing. And we separated them out in two separate independent Node.js applications. So for the purpose of this video, we are going to take a look at one of the middleware component and then the UI, which is written in Ionic framework based on AngularJS. So let's start with taking a look at the orders application and then see how we have converted this Node.js application into a Docker. The products component is going to look exactly the same. So even if we do not dive deeper into the product component, rest assured that the execution is exactly similar to that of the orders. So you are not going to be missing anything at all. Like any node application, the first thing that we look at is the package.json. Package.json provides basic documentation, but at the same time, it also provides a list of dependencies that are used in our application. Before you initialize your application, the first thing that needs to be done is installing these packages, and that is done using npm. So if I were to go into this directory and I would say npm install, this would install all the dependencies based on the package.json and put them in the node_modules directory. So as you can see in this project, we have used body parser, express, and MongoDB client. Another thing to note in this application is the start script. Provides a command to start the Node.js application. Now let's take a look at the actual application that is written in index.js. Like any other node application that utilizes Express, there are some very initial basic constructs such as declaring the host, the port, the body parsers, initializing the Express app. We have also set up a configuration to initialize our MongoDB client. This is where I want to point you to the config parameters that we will see in a bit that specifies the user, the password, and then the server along with the database port that is being used. Because we are at this point, let's take a look at our config.js. This is not a mandatory construct, but just something that typically developers like to externalize some parameters. As you can see here, we have created a bunch of parameters for our database, and this config file can then be extended for any other parameters as the application grows. Give special attention to the server that is specified here. Assuming this is going to be deployed into production, the server name for the database is the database service, which is MongoDB service. We will take a look at where this service is created and how this is initialized in our second part of the video, where we start looking at deploying the containers into Kubernetes clusters. But for now, just note that the host name is not any specific IP address or a host name. It is the name of the database service. So this is the basic construct of our Node.js application. Let's first run this Node.js application locally and test it out. To test, we are going to use the ping endpoint to check whether the application is up and running. One way to start the Node application is by running the command node index.js, and this shows us that the Node.js application is ready. Let's quickly pull up our browser and test that endpoint on port 8080. We are able to access the order endpoint for this application. You might be seeing some errors related to network connectivity, and this is specifically that the Node.js application that we just started is not able to connect to the MongoDB database. And that is so because we have not really created or deployed our MongoDB service on the Kubernetes cluster. So until then, the Node.js application can still run. It would just not be able to perform any functions that need a database. Now that we have verified that our application is working fine locally, it's now time to create a container image out of this. Please note, our objective is not to run a container at this point, but just to create a container image which will then be pushed to a container repository. In the next videos, we will then see how this image from the container repository will be used in Kubernetes to deploy the application as a microservice. So the way to create a Docker container image is through something called as a Dockerfile. Dockerfile is a document that contains instructions on how to assemble this application. So taking a look at the Dockerfile for our orders application, we first see that we are first going to refer to a container image called node. Once that node container image is downloaded, we define where the working directory is inside that container image. This is not a directory or a file system on your machine, but on the container machine. We then copy files from our current directory to the target directory. So if you look at this instruction, what it literally means is we are going to copy all these files from our orders application into the target directory, which is the USR app. At this point, we are then ready to run npm install so that all the packages defined in our package.json are installed on the container image. The last line is basically a documentation mentioning which port our application is going to run on. So we can verify this from our index.js, where we have mentioned that the port is 8080, and that is the port on which our application is going to listen. Once the assembly is done, we can now have the container run an application inside the container upon its startup. And that is provided by the cmd command. So the cmd command runs the command npm start once the container assembly has been completed and an actual container is created from this image. So now that our container image instructions are complete in our Dockerfile, we have to now create a container image. So let's go to the command prompt for that, and let's go into the directory where this Dockerfile exists. The command to create a Docker image is docker build, and then we need to tell where our Docker file is. So the Docker file is in the current directory, and therefore a dot should represent our current directory. But before that, we need to name our Docker image. This is done using the -t flag, which tags the application and its version. Now, because we plan to push our container image onto the Docker Hub, which would be the online container repository, we are using the namespace of our Docker Hub, and that in my case is mppic. The name of our application is order, and I want to say that this is version 1.0.0. This command is now gonna build the container image, and this container image will first be available on your local machine before it is being pushed onto the Docker Hub. Let's check the container image. The command to check the container image is docker images, and this is where we should see that mppic order with the tag 1.0 was just created and is a total of 943 megabytes. Now I want to take you to the Docker Hub. We're going to take a look at the Docker Hub and first verify that no container image is available in the online repository. The command for that is docker push and the name of the application. We have to always make sure that we specify the correct tag so that the correct local image is pushed to the Docker repository. Now the Docker container image from our local laptop is pushed into the online repository, and let's verify that. So if we refresh this page, we now see that mppc/order was just pushed a few seconds ago. And if you look into the details, we should be able to see that the tag just pushed a few seconds ago was 1.0.0. Just like we have created our Docker image for our orders, we would follow the same process for creating our Docker container image for products. And the way to do that is we first test the application locally, we then build the Docker container providing a name and a tag, and once the image is created, we would then push the Docker image onto the Docker Hub. And if we now go back to our Docker Hub, we would now see two applications, which are two Docker container images available on the Docker Hub. Now that we have created our container images for all the middleware components, we are now ready to move to our user interface. Our front end is built using Ionic framework on AngularJS, and so the assumption here is that the entire build is complete for our application. Just like you would test your Node application, you could locally test your front-end application on your laptop. We are at a point now when the application is running and we are ready to create a Docker image for our front-end components. So the assumption here is that you already know how to develop and build an Ionic application. This is a documentation page from Ionic that shows how to build an application with different switches. In our case, we have already built the application and our application is now created inside the directory www. Our job is now to create a containerized image of the contents in the www directory. In order to proceed with that, we have used a similar construct here of a Dockerfile. The Dockerfile is referring to a container image called HTTPD. HTTPD is a Docker official image that provides an Apache HTTP server project. And the documentation page provides details about where the contents of your HTML and JavaScript files need to be copied into. We follow the same instructions into our Docker file and are ready to create a Docker image. So just like the Node application that we saw earlier, we are going to build our Docker image by using docker build -t mppIC/webapp, and the version for this is also going to be 1.0.0. Once the Docker container image is created locally, we need to then push the Docker container image onto the Docker Hub. That should complete our Docker container image creation. Let's just one last time go onto the Docker Hub and verify that our image is really available on the Docker Hub repository. And it is. So what we learned through this entire exercise is how do we take an entire application and first break it down into smaller components. These components could then be individual projects or repositories. The application code from these components is first then tested locally, and then once we are ready, we create a container image using the Dockerfile. This container image is first created locally, which needs to be pushed into an online code repository. This code repository is then available for the next steps, which is to use them in Kubernetes deployments.